and this is the second part of the Oregon spot frogs. And the data are from Tidy Tuesday, week 31, and this is my second plot. So the first part of this video, we have seen the many models for the frogs dataset. Now we are going to see with the rock plot. Now we are going to see the second plot, the variable importance plot, and there will be other parts following this one here to finally complete the whole visualization. So this is the plot that we are going to build now. As you can see, there is a list of variables, and the main objective of our investigation of this data is to see what is the proportion of females and males within Oregon frogs, species Rana pretiosa. So basically, we want to see who is more likely to be captured, if it's a female frog or a male frog. So, okay. Let's start sharing some R. So we can see. Okay. So I've already loaded, I already put some code here. So you need to load tidyverse and tidy models, because to do this plot, we need the recipe package. So this is the data set, the frog data set. So we see what's happened here. When we load all data set and the packages. Okay, so now we have a quick look at the data. Again, we have already done it on the first part, but we see it again. So here we have a site, which is just one type of variable, so the Crane Reservoir. Then we have the subsite, which are the pond and the river in some location of the Crane Reservoir. Then we have the habitat type, which is pond, river, and reservoir. The survey date, which goes from late September to November 2018. The ordinal, which are the days of the year. The frequency. This is the radio-telemetry frequencies. They use it for catching the frogs' movements in the crane. And then the geolocation in meters. Then there is the interval. This is the main vector which are interested in. So it's female. So 0 means the reference variable, female, and 1 would be male. Then we have more variables, the type of the water, the specific type of water, the structure, the substrate, if there's any beaver, where are they? And then finally, if the frogs are detected, so captured, visualized, or non-visualized. So to make the visualization, we have just seen. What we do is do some arrangement of the data. So we do some cleaning. So we take the frog data set. Then first thing we do janitor clean names in a way that So this way we have all the titles in lower to lower. So that would be easier to manage. Then, as you can see, the date, it's a character. So we modify the date to be as date. So we have this survey date, be as a date. And when you do as date, it's important that you specify this, how the date is. So you need to, if you have this type of variable and you have the date, which is in this format, like you have the month, the day, and the year. When you transform this vector, this character vector as a date, you need to specify the way it is. Like you need to specify that it is a month, there is a year, a day, and then finally the year, which is a capital Y, because it's 4-character year. So okay. Then what we do is, as we are interested in female, so this is our factor variable. We do set this as a factor. This is what there is not much to see, by beside the fact that this is now a date and female is a factor. Okay. So now we arrange this by the ordinal. So the ordinal, which are the day of the year, will be ordered. They are already, but we make sure that they are. Okay. And then we don't need a site. We can do this, or we cannot. We can even not do this because with recipe, if you use the step 0 variance, that means that it will basically select just the variable with one, just the vector with more than one variable. So, but we do this to use just one step in our data set. So we have now we haven't the site vector anymore. Then finally, what we do is to change the names of the subsite. As you can see, the subsite here, if we have a quick look how it is. We can see that we have cow, camp, pond, river. This is Nord Reservoir. So we like to have that in the visualization written clearly. So we take, we do a little modification, okay, of the names. So what we do is to case when, so we mutate subsite to be as when subsite is west, for example, reservoir, it would be West Reservoir written clearly, as well as Southwest Pond, Northwest Reservoir, and so on. So this way, if I do again count, which is a way to summarize the table, this vector with relative frequencies. So I do again count subsite. Now I have the elements written clearly, so within the full name. So now this is our, I don't know that. So now this is our new tidy data set, and we call it frogs1. Okay, so now that we have a nice clean data set with the variable set as we want, we can start building up our visualization. And how do we do that? So first thing, we need to use the receipt package and make a receipt. In the receipt, we put our female vector, and on as a response variable on all the other predictors in our frogs dataset. So this is a receipt from tidy models. And as you can see, the outcome is 1, and the predictor are all the other variables. We are not going to make a model. We're just using a step, the receipt package. We now, so we're just making this the second part of our modeling. So let's say that we have done the modeling, and now from this, we are working on the modeling, and now we are we want to make variable important visualization. So for now, we just use this recipe, and then we prep and bake with new data null. So we can see that again, the our data set is back. So nothing changes basically. So we have set some formula to be used. We are not going to use it. So this is just for to show you that what's happened when you use the recipe, set up the formula in case you want to use some steps. This case, we are not going to use the steps, but we do some, again, little modifications to see what is happening to make the visualization that we want. So this is again a little tidy modification. So we modify female as to be clearly written, not just 0 and 1, but female and male. So in a way that it will appear in the data set, in the legend of the data set. Then we now filter the detection has to be just captured. Okay, so they are all just captured frogs. So we exclude visualized and not visualized. Then again, we rename the habitat. The habitat type has to be habitat, so that would be nice to see in the visualization. Then finally, select just some of the variables. So I'm doing this because this is the script that you find in the container of the GitHub repo. There you'll find all the reference in the description in the file. So we now select just female in the YouTube channel. So we select just female, subsite, habitat, water, structure, and substrate. So these are these five vector will be the elements that we use for making the variable importance visualization. This is our set that we are going to use for making the variable important visualization. So we have female, subsite, habitat, water, structure. Now female is clearly stated, as well as subsite, and the other elements are quite interesting as well, because we have the water, which is shallow water, no water. We can even see exactly. We already done in the other video, but just to remind ourselves that we have deep water, no water, and shallow water, as well in the structure. We have herbaceous, vegetable, open and woody debris, and then in the substrate, there's a flock, mineral soil, organic soil, and unknown substrate. What do we need is to make the visualization. We do nice pivot longer. So we now transform the data in a way that the subsite, and so all the variable from subsite to substrate will be to subsite to substrate. So all these variables here will be all set into columns. One column would be named features, and there you find the names of the variables, of the vectors. And then the second column will be the value with the content of all these vectors. As you can see, the transformation is this. So you have now your female, the features, and the value. So now female is a character because we change it here as if else female male, and because I've used this the tidy bit part of the initial frogs dataset from the modeling. The fact that the female vector has to be a factor in this case is not needed. So we can even transform it as a factor again, putting here as a factor female, like female again as factor, and then female. And we can see that now female is a factor. And then what we do is that to make it nice, we need the feature, this one here, the element inside the feature, to be to upper. So that would be, it would be nicer to see. Okay, so finally, now this is our data set. We can even do a little modification, like see what's happened if we don't use this, but we just continue with the modification from this data set. So we like take this off because we don't need it, and continue from here. So we have the same result. Okay, so this is what we need. So we like set the code a little bit better. We don't even need to do that. And what else do we need? I don't think we need to do this as well. We can just comment them out. Okay. So these were all steps that I used to while I made a model, the model. So now it's not actually needed to do all these things. Okay, I think we can. We have like transform the data set in a way that is more readable and faster set just for making this visualization. So now what we can call it this data set plot, and we have this data set plot that we are going to use to make the variable importance. Okay. So we do the ggplot, and set the aesthetic has to be just we need y, which is the value, and the fill equal to female, and then we do a geom bar position the geom bar position fill. Okay, let's see what's happened if we do that. We need to make this bigger. Okay, so this is our starting point. So now we have like the counts in percentage of female and male. So female are this reddish bar, and these are bluish bars for males. So we can see, like, for example, these are all the variables inside the different vectors. So listed by importance. So the river, shallow water, the different elements. For example, in the shallow water, you can there's So because I have selected just the captured frogs, so they are all just captured. So we are not considering visualize or no visualize. So in the shallow water, for example, like more than 50% captured frogs are male, while the other are females. And so on for all the other elements inside the variables. Okay, like in the North Reservoir are all male, the frog captured in this data set. So now we make it like fishing this visualization a little bit better. We can add a vertical line with the geom v line, and we can set the aesthetic or not set the aesthetic. Okay, we can, because we are not using in the step, we are not using element of the data set, so we can even set this to 50% and it works. Oh, that's nice. That's nice. Okay. Can we do that again? I don't know why. But anyway, so likely we haven't saved the script. But it's all good. So now again we have this. You can see it. Okay. So, and here you go. You have this this line. Now, if I do that with an aesthetic, you can see this is just the same. Okay, so this is just the same. Okay, we finish like making our plot a little bit better, and what we do now is adding a facet grid. Okay, this step, in this step, you can see that now the elements are a bit more specified. Okay, it takes a bit. It's not okay. So now our vectors, so our the predictor that we have then used it in the model and everything, so are specified. So we have the habitat here, the structure, this and the subsite, substrate, and water. You can see everything nicely. And then finally we have some other features that I'm going to just attach them here because time is up. And but we are going to them and say, so after the facet grid we add the titles, so we use the labs, we set fill, which is the legend here. Cannot be seen, but you change the name of the legend to be who is more likely to be captured. You can even add this this /n to go on the second line. Then we said I didn't put a title because in the main visualization this goes on a side. There's a main title of the whole visualization, so I just did a caption with gender dependency VIP classification. Then the color, specify type qual, which is this nice those two nice color of the visualization. Then the scale continues with the percent, and then expand. It's for like taking these elements. It takes a bit to show. Okay, this grayish part on the left and the right side will be covered with the bars using this expand. And then the tem elements, setting the family for the type of characters to roboto condense, the size, and then some other specification for the caption, axis, backgrounds, and things. So if we run this, we can see that again. I don't know why, maybe because my computer is a bit like overcrowded of things. Anyway, this is the visualization, and this show up. Okay. So this is the final visualization. What we have had are the percentage here, and we did it with this label scales percent. So we use the scales and percent to have this percent sign here. We changed the family, which is the character of the visualization, to be a roboto condensed. So now it's a bit like squeezed in the here in the plot pane to be visualized clearly, but then you save it with ggSave, and you can, like, when you do ggSave, you can like set the dimension of the image that you then are going to use or save or put in another plot. So let's go back to our final visualization. And see that the final output of our visualization is this one here. Okay. So I used ggSave and set some dimension like the height, the weight, so the pixel. just to have the dimension I needed to put in the entire plot. So the plot, I'll show you now what is the final plot that we are going to build. And it is this one here. So this is the final plot. Okay, so in the first video we have seen that here on the bottom right corner there is the receiver operator curves for selecting the best model. Now today we have seen this other one, the variable important, on the left side with the bars. And then we are going to see how to make this lake map and the network at the bottom, at its very bottom. Okay, so hope that's useful somehow. See you in the next video.